In this video, we are going to learn how to determine limiting reactants and learn how to use those to calculate theoretical yield. So here are the here's the breakdown of the learning targets. Know how to determine the limiting reactant from your data, know how to determine the amount of excess reactant left over, and then determine the amount of product based on your limiting reactant. So what is a limiting reactant? Okay, a limiting reactant is one that is consumed first in the reaction. Don't worry about this honors up here. This is for everyone. So limiting reactant is the one that gets used up first. Excess reactant is the one that's left over. Okay, you'll still have more left when the reaction is finished. So for example, if you're going to start your own sandwich shop, notice the fancy French words there for shop. Your specialty is the superhero sub sandwich. So your recipe is this: 2 breads, 4 hams, 4 tomatoes, 3 roast beefs, 2 turkeys, 10 pickles, and 3 lettuce. Is going to give you 1 sandwich. So now you're novice, you're new to this. So here's your inventory. You got 10 bread, 30 ham, 8 tomato, 15 roast beef, 18 turkey, 100 pickles, because they come in big jars, and 30 lettuce. So how many sandwiches could you make? So what you could sit down and do is come up with each one of these and tell how many you could do. So if you have 2 pieces of bread per sandwich and you have 10 breads, you could do 5 sandwiches. 30 hams, you got 4 per ham, so you could do 7, and you would have a couple of slices left over. 4 slices of tomato, you only have 8 slices of tomato here, so you could do 2 sandwiches. 3 roast beef per sandwich, you got 15, you could make 5. 2 slices of turkey, and you have 18 slices of turkey, so you could do 9 sandwiches there. Big jar of pickles, you could do 10 sandwiches. You could do 10 sandwiches with 30 lettuce. So what's the maximum number of sandwiches that you could possibly make? It's going to be 2 here because you only have enough tomatoes to make 2 sandwiches. Okay, so I'm sure in the future you'll be better at planning your inventory. So let's look at what this looks at like in a chemical reaction. All right, so if you're in chemistry class, and I give you 25 grams of lithium, which won't ever happen, that's way too reactive, they won't even let me have it, and 30 grams of bromine, how much lithium bromide would I get? All right, and here's our reaction. Now, how much means grams. Okay, so make sure you're looking for grams here. So assuming that we've already done our stoichiometry setup here, 2x, x, and 2x, we do have to set up all of these because what we're going to do is we're going to actually have 2 x values here. We have to figure out which one to use. So if we start with our lithium, you can do 25 equals 14x. So x, if lithium were used up, would be 1.79. Now we have to do the same thing with bromine and figure out what the x factor would be if we used bromine. So if we start with 30, and that's 159.8 times x, our x value here would be 0.188 moles. Now what you do is you pick the smaller one. All right, so here is x, the smaller value for x. So this is going to be our limiting reactant. All right, so bromine would be our limiting reactant. It's going to get used up first. Okay, it's going to get used up first. So now we go back and we use 0.188 for x, and if we put that, and we need to do this for lithium too, and I'll show you why in a minute. 14 times 0.188 is going to give us 2.63 grams of lithium. We plug that into our lithium bromide, and we end up with 32.6 grams of lithium bromide. So this is the answer to the question, how much lithium bromide would we get? Now this information, the 2.63 grams, that tells me how many grams of lithium are used in the problem. See, we use all 30 grams of our bromine. That's our limiting reactant. It gets used up. We only had to use 2.63 grams of lithium for this reaction to take place. So we can figure out how much lithium we have left over by subtracting. All right, so we can do 25 minus 2.63 grams, and that would tell us, I'm going to round this, we would get 22.4 grams of lithium left over. Okay, so we used up those. But our answer to this question here is 32.6 grams of lithium bromide. So find both X values, pick the smaller one to use. Okay, and then you can solve for everything else. So let's look at one more problem. All right, so here's our problem. How many grams of barium sulfate will be formed if 200 grams of barium nitrate and 100 grams of sodium sulfate? And then if 155 grams of barium sulfate were produced, what is the percent yield? So we've got a lot to do in this problem. Okay, so I've gone ahead and labeled my equation, 200 grams of barium nitrate, 100 grams of sodium sulfate. I'm looking for barium sulfate here. Okay, so we do X, X, and X. And of course this one is 2X if we were doing that one. And I have my molar masses here. So I get 261.4 times X, 142.05, and you can round that to 142. 233.45x. So we need to solve for our x values down here. So 200 equals 261.4 times x. We do our math there. Our x value is 0.765 moles. We're going to do the same thing here. We get 100 equals 142, excuse me, 0.05. X, again, it's okay to round that. You get 0.18. Oh, sorry, I'm looking at the wrong problem. Let me erase that. Your X factor here is 0.704 moles. So not much difference, but this one is a little bit smaller. So this is the X value that we are going to use. All right, so if I multiply X by everything that's used, we don't need to do that one, and over here we get 164 grams of barium sulfate. So this is my theoretical yield, so I can use it for my percent yield. So I get 155 from my problem here over 164 times 100. So my percent yield, and I forgot to do my math, give me a second, is 94.5%. Okay, so there's my percent yield, 94.5%. And then it says how much excess reactant is left over. So if I used 184 grams, I can do some quick calculation. 200 minus 184. That means that I have 16 grams of my barium nitrate left over. So my limiting reactant in this problem is sodium sulfate. Barium nitrate is my excess. I have 16 grams left over. Percent yield was 94.5%.